If I just go through these ones from mixed practice 16 then, which were 8, 9 and 13. The first thing about question 8 is how we convert between kilometers an hour to meters per second. Kilometers becoming meters is times by 1,000. The hours, how far you travel in a second compared to an hour, you divide by the 60 and you divide by the 60 again. So divide that by, or times by 1,000, divide by 3,600, or just divide by that. 40 divided by 3.6 becomes that. 10 divided by 3.6 becomes that. Half divided by 3.6 becomes that. Now, the second part of it is find the acceleration of the car in terms of t. Acceleration is the differential of velocity with respect to time. That term disappears. 25 over 9t becomes that. That becomes that. Hence, find the time when the car has maximum velocity. We've got to be careful about saying maximum velocity is when the acceleration is 0. It depends on the shape of the graph, doesn't it? In this case, that velocity graph, a quadratic in terms of t with the coefficient of t squared negative, that is a graph that looks like that. So the stationary value is the maximum. So it is valid to say when that is 0, because we get a maximum v when a is 0, but only because of that. We'll come back to that. And we get time is 10 seconds. C, the displacement of the car when t is 12. If it's displacement, you can simply integrate velocity between your starting value and the time we want the displacement at, which is 12, which you can do on this calculator or the graphical calculator, can't you? You can integrate the limit between limits. That's a definite integral. Or you should be able to do that longhand from the pure we're doing. Which brings us to part D. If it's modelled as a particle, is that suitable for when it's overtaking a van? It's all about whether the car's length is comparable or negligible compared to the distance it's travelling. Because a car's length is comparable to a van, because these two things are similar, the particle model is not suitable. But if it's going through a tunnel which is 380 meters long, then the car's length is less, much less than that, and it's negligible. So it is a suitable model for that. So that was question 8. Question 9. I thought the easiest way of doing this one was to visualize it using a diagram, but I always think a diagram is the best way of doing it, don't I? So the bus was traveling in a straight line. The man was going to be running in a straight line. The bus is travelling at 8.5 when it passes someone and then decelerates uniformly. Straight line graph comes to rest. The man starts running immediately at a constant velocity, a horizontal line. They both arrive at the bus stop at the same time. The distance travelled and the time taken are the same. The distance travelled is 44.2. That's the area under both graphs. For the bus, it's a triangle. Half base times height, half base times height. Rearrange that, you get the time is 10.4 seconds. For the man's graph, it's a rectangle. So the 44.2 is that, multiplied by that, gives that. Could you do it as Suvat? Of course you could do it as Suvat. Suvat, we had the initial velocity, we had S, and we had the final velocity. So I would use S equals U plus V over 2 times T. S half 8.5 plus 0 times T. Right, that is identical to that, isn't it? It's not a coincidence. So it doesn't matter which you do because they're the same method. Time is 10.4. Man travels at constant velocity. 10.4 times his velocity would be the 44.2. Same working. Question 13 is a good one. Particles moving in a straight line, so its displacement from the starting point is given by. So the displacement is given by this. And we want the maximum speed. In order to be working with speed, we need to be working with the velocity. Velocity is the differential of that, and we get this expression. which is that. It wanted the maximum speed. Maximum speed is not the same as asking for maximum velocity. Maximum velocity is the biggest positive value or the least negative value. Maximum speed could be the biggest positive or the biggest negative. So I would always sketch that. V is a cubic with a t squared, a repeated root, and a single root. That one at 5, this one at 0. Repeated root means it touches the axis and goes away again. Just the root means it crosses the axis. Minus t cubed means it's that shaped graph. Right. The maximum speed in the first 6 seconds, well, the maximum velocity has to be this point. That's the point of the maximum velocity. But that point or that point could be the maximum speed. To find the local maximum, differentiate, put the differential to 0, get 10 over 3, find that when t is 10 over 3, the velocity is that, but then check when t is 6, the velocity is that. So the maximum speed is 17.3. It's a beautiful twist, okay? Just always check, are they asking for maximum speed or maximum velocity? And come back to the shape of the graph. And there's no excuse not forgetting that, because you've got graphical calculators, haven't you? So that's the mixed practice 16 ones done. I'll now do a video for the mixed practice 17 ones.